Hello class, this video is Tuesday night, for Tuesday night, and I'm giving you about 2 nights to watch this, so if you guys have problems getting internet or stuff like that, I'm giving you, or you have a game, or you're busy, I'm giving you 2 nights to watch these videos and we'll go over in class. If you want to turn your notes to the last page of your notes, it's section 2.5, and again, yeah, there's a lot of things that are misspelled here, so I apologize for that. So instead of fundamental, it should be fundamental theorem of algebra. And we're not going to go through this whole thing, so it's going to be actually a shorter video. But I'm going to teach something, it's called the Descartes rule of sign. So I'm going to type it here, and maybe you could just write it in your notes. Descartes rule of signs. Okay. So Descartes rule of signs, we'll just put it here also, is one of the objectives. Okay. So the fundamental theorem of algebra is quite complicated, but it's actually simpler than it sounds. It says for every polynomial with a power greater than 0 has at least one 0 in the complex number system. The power of x tells maximum number of zeros, and if you have a complex 0, then the conjugate is also a 0. So for example, if 3i is a 0, then negative 3i is also 0. Or if 4 plus 6i ends up being a 0, then 4 minus 6i always also ends up being 0. So fundamental theorem of algebra, let me summarize these three. If you have a power greater than 0, that means there has to be one solution or at least one 0. Okay? The power of f of x, or the degree, tells me what's the maximum number of zeros. So if you have a degree of 5, there's 5 zeros. A degree of 10, 10 zeros. Okay? Fundamental theorem of algebra. And then if you have a complex 0, the conjugate, we talked about that, blah, blah. So let's move on to the bottom. And we're not going to answer these like it is here, but I'm going to teach you again the Descartes rule of signs. So here's to find the zeros of the polynomial function. So first thing I'm going to do is figure out what's the degree of this problem. Okay, it's already in order for you, but the degree of the problem is 5. So let me just write it out. I'll type out the degree is 5. So that tells me that there has to be 5 solutions to this problem. Some may be real, some not real, but I know that the degree is 5 there has to be 5 answers based on my degree. The next thing I'm going to do is I'm going to use Descartes' rule of signs to tell me how many possible positive and negative answers there are. So maybe you could write this in your notes. It's a Descartes rule of signs. And it says if you have f of x and if you have f of x, count the amount of sign changes. Okay. The amount of sign changes tells you how many possible positive solutions there are. Every multiple subtracting 2 is also possible. And that might make sense to you, but if I give an example, it'll make sense. In reverse, if I plug in a negative x, if you have negative x, count the amount of sign changes. And I'm just going to copy and paste this, but the amount of sign changes tells you not how many positive solutions are, but actually how many possible negative solutions there are. Every multiple subtracting 2 is also possible. So let's look at this example right here. Okay. So I got x to the 5th plus x to the 3rd plus x squared plus 12x. So with Descartes' rule of signs, I'm going to first count how many sign changes there are. And some of you may be confused. Well, let's look at this. From x to the 5th, or x to the 5th is positive. X to the 3rd is positive. 2x squared is positive. Negative 12x is negative. And then plus 8 is positive. So going from left to right, let's see how many sign changes I have. From plus plus, no. Plus plus, no. Plus minus, yes. So I have one sign change here. And minus to plus, I have a second sign change. So that tells me that there's 2 or 0 positive solutions. Again, excuse my writing. I'm using a mouse. So there's 2 or 0. Okay. Now the second part of Descartes' rule says plug in a negative x. Okay. When I plug in a negative x, what that means is that all these let me delete this real quick. It means that every odd exponent will change sign. So if I plug in a negative x here, do you see how this now becomes negative x to the fifth? Actually, here, let me write it out for you. If I plug in a negative x, this now becomes negative x to the fifth. Sorry, it's supposed to be f of negative x equals negative x to the fifth. This x to the third will now become negative x to the third. Here, see how it's x squared? So if I plug in a negative, it's still going to be positive. So this is going to stay plus 2x squared. Here, this is technically x to the first power. So if I plug in a negative x, that'll turn into a plus 12x. And then this plus 8, there's no x there, so it doesn't change sign. So do you see if I plug in a negative x, how this becomes negative, this becomes negative, this stays positive, and then this becomes changes sign to positive. So instead of plus, 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 minus, plus, let's see the new signs. I have negative x to the fifth, I have negative x to the third, I have positive 2x squared, I have a positive 12x, and I have a positive 8. Now, can you count the sign changes in this one? Yeah, there's only one sign change right here. So there could be either 1 or 0 negative solutions. Okay, so far? And really, after this, and this is the only thing I'm going to ask of you after this part, is after we do this part, you could delete this part, and you won't need it anymore. I don't know how to delete, so never mind. What you're going to do is now you're going to do the rational root test, a rational zero test. Remember from our last, let me scroll down, remember from our last problem we did P over Q? Yeah? Where P represents the factors of the last problem. Again, I told you this is where I messed up last night. So P is 8. Okay? P represents 8. So what are the factors of 8? Well, there's 1, there's 2, there's 4, and there's 8. And all of them will have what in front of it? Yep, plus minus. Plus minus, plus minus. And it's really messy, but you know these are all plus minuses. Q represents the first term. So do you see how the first coefficient is 1? So what are the factors of 1? Yeah, just 1. So now, all the possible answers is just P over Q. So 1 divided by 1, 2 divided by 1, 4 divided by 1, 8 divided by 1. So all the possible rational solutions to this problem are just plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So there's really more to this step that I'll teach you guys in class. But essentially, you know, there's supposed to be 5 solutions. 2 or 0 can be positive. 1 or 0 can be negative. And some of you are wondering, that doesn't make sense. There's supposed to be 5 answers. At the most, there's 3, right? Well, if it's not positive, and if it's not negative, that means it could be a complex solution. So for example, I'll put another color. There could be 2 positive solutions. There could be 1 negative solution, but that leaves me with 2 more solutions, right? So there could be 2 complex solutions also. Or, what if I had 0 positive solutions, I had 0 negative solutions? That tells me that how many complex answers do I have? Yeah, 5. To make a long story short, this is a long process, and I'm just giving you the pieces of each step. The very, very first step you're going to do, just to refresh your memory, is you're going to find the degree. In this case, it's 5. I know there's 5 answers. After I figure out the degree, I use Descartes' rule of signs to figure out how many of those answers are positive and how many of those are negative. And once I do that, I'm going to use the rational root theorem to see what the possible answers are. So do you see here there's 8 possible answers? There's positive 1, negative 1, 2, negative 2, 4, negative 4, 8, negative 8. So there's 8 possible answers. There's supposed to be 5. And I know you guys can think logically and figure out what to do next is test all 8 and see which of these are the answers. So I'll teach you more tomorrow. I might teach another video tomorrow night. So I hope you enjoyed this video, and I'll see y'all in class.